All of the problems covered in my videos can be downloaded at statisticsworkbook.com. If you go to the website, click on the PDF. You can download a copy of the workbook for yourself. Also on the website, you'll find links to all of my statistics videos, not just the ones I've uploaded to YouTube. I've uploaded nearly 100 videos that you cannot find on YouTube. So, I do hope you'll check out statisticsworkbook.com. Alright, let's begin our problem. Hello and welcome back. In this exercise we're going to look at this concept of conditional probability, and we'll start to look at this thing called the multiplication law. We'll sort of derive the multiplication law here. We're not going to use it explicitly, but we'll see where it comes from. So the data that we're looking at, I've done a survey. An alumni association has done a survey to determine labor market outcomes for their recent graduates across these different fields, business, science, and arts, and we wanted to know that you obtained full-time or part-time employment upon graduation. So here in this data set, I've got, for example, here I have 23 business students obtained full-time employment, 46 obtained part-time employment. Arts, 51 full-time employment, 13 part-time employment. So we've got the different combinations of field of study and employment status. And then over here we have the total number of full-time, total number of part-time, total number of business, science, and art students. So we've got here a cross-tabulation of the relevant data that we can now use to put together this joint probability table. So what I'm going to do for the joint probability table, I've got, as you can see here, I'm just going to scroll down a little bit, I've produced two side-by-side tables. And the reason being is that I want to focus a little bit on the notation that is used. I find, for the most part, this is the first time that a lot of students are exposed to the notation that is used in probability analysis, and so that can be somewhat tedious to deal with. So I've got two tables. This one will be our joint probability table. Oops, probability. So everything we put into that left table, that will be our solution for part A. Over here, this is just going to be a table of notation, just so that you can sort of connect the dots between what numbers correspond to what notation. So before I actually fill in the numbers, let's go through the notation first. So what we're going to have in this space here, this is going to be the probability that a randomly selected student, randomly selected graduate, is a business student who obtained full-time employment, right? So that's the cell that corresponds to a business student and full-time employment. So this is going to be the probability that it's a full-time student intersection business. Okay, so everything sort of within that table, excluding the totals, within that table, those are all the intersections. So this one is going to be the intersection of full-time science. This one is the intersection full-time arts. This one is the intersection of part-time business. Here's the intersection of part-time and science. And finally, here's the intersection of part-time arts. So those are all the intersections of these two events, okay? Now, the marginal probabilities are those things that are going to go here and here. Those marginal probabilities, well, those are just, in this case, that's the probability that a randomly selected graduate is obtained full-time employment. Over here, this is the probability that a randomly selected graduate has part-time employment. Down here, probability of drawing at random a business student, a science student, or an art student. That last corner, we don't really care what that is. That's always going to equal to 1. Nothing interesting there. So here we have all of our notations, and this is going to make more sense. Hopefully it will help when we put together our calculations for conditional probabilities, because we're going to need a few of these different entries. So let's go ahead now and calculate our joint probability. So for the first one, the probability that a randomly selected student, graduate, is a business student who obtained full-time employment. So here I have 23 out of 193 students that meet that criteria. So the probability that I select one at random, so here we're calculating, I'm not going to write these down for all of them, but here we're calculating that intersection of full-time business. I have 23 that meet that criteria out of the 193. So that probability is going to be, let's get the calculator somewhere else, 23 divided by 193. So that's a probability, let's round that to 0.12, 0.12. Okay, so that's the intersection, the probability that a randomly drawn student is both a full-time business student. Okay, so we can, let's go ahead and fill in the rest of them. For all of these calculations, I'm going to be using, let me color code these. So all of these black circles that I'm going to use first, those are all going to be those intersections. They are all going to be divided by this same denominator. So all of the calculations are going to be done with 193 as the denominator because that's our total number of students. Okay, so let me move this over. So let's continue on the full-time category. So the next is science. I have 42 science students out of the 193. That's full-time science students. That's 0.22. Oh, let's keep our colors here. So that's 0.22. Next, I have 51 art students who obtained full-time employment out of 193. That's 0.26. Okay, and let's continue on with the joint probability. So I'm going to move down to the part-time row. So that's 46 business students obtained part-time employment out of 193. So that's 0.24. Part-time science. So that's 18 out of 193. That's 0.09. And finally, the arts part-time is 13 out of 193. And that's 0.07. Okay, so there we have all of the intersections of these two events, right? Field of study and employment status, full-time or part-time. Now we can get the marginal probabilities, and so now as numerators I'm going to be using these values and these values. Still the denominator is going to be that 193. So let me write down for the first one. So if I'm looking at the probability that a randomly drawn student will be a business student, so this is probability of business. This is going to be 69 over 193, and 69 divided by 193 is 0.36. And let's just move along that row. So now the probability of randomly selecting a science student is 60 out of 193, so 0.31. And randomly selecting an art student would be 64 out of 193, 0.33. Oops. And then we can do the same thing now on the full-time and part-time status. So here I'll write out the first one. So this is going to be probability of full-time employment, 116 divided by always 193. So 116 divided by 193. So that's 60%, or 0.6 I should say. And I know that the next one, these all have to add to 1. So I know the next one is going to be 0.4. Because all of these values down this row down that column will add to 1, and everything along this row will add to 1. So this is just going to be 1, nothing interesting to extract from that piece of information. Okay, so now we have our joint probability table. We've responded to part A. Part B, interpret the marginal probability. So what do those probabilities mean? Essentially, all it means is that if I reach in at random and I pull out an individual, there's a 0.6 probability, or you can say a 60% chance that I will randomly select an individual who obtained full-time employment. Or there's a 40% chance, a 0.4 probability, that I will randomly select somebody who obtained part-time employment. And the interpretation across the field of studies exactly the same. A randomly selected person is a 0.36 probability, or a 36% chance that I'll draw a business student, or a 31% chance that I'll draw a science student, etc. Okay, so that's what these marginal probabilities, those are the blue ones in the table, that's what those are telling us. So now we get into the interesting ones, finally. You know what, I'm actually going to do another video here, because this has already gone on for almost 10-11 minutes. And now part C, we're going to start to get into some of the actually more tricky calculations. So let's end this video here, and I'm going to start up another one right away. Okay, thanks for watching.